Welcome to aminacademy.com. In physics, let us discuss about electric charge and electric field, some introduction. Have you ever experienced to see what happened when lightning in sky? This is a good example of electric discharge is the lightning that we seen in the sky during thunderstorms. We also experience a sensation of an electric shock either while opening the door of our car or holding the iron bar of a bus after sliding from our seat. The reason for this experience is discharge of electric charges through our body, which were accumulated due to rubbing of insulating surfaces. You might have also heard that this is due to generation of static electricity. This is precisely the topic we are going to discuss in this video. Static means anything that does not move or change with time. Electrostatics deals with the study of forces, fields, and potentials arising from static charges. Electric charge, which can be positive or negative, occurs in discrete natural units and is neither created nor destroyed. Electric charges are of two general types, positive charge and other is negative charge. Two objects that have excess of one type of charge exerts a force of repulsion on each other when relatively close together. Now, what is electric charge? Basic property of matter carried by some elementary particles that governs how the particles are affected by an electric or magnetic field. Electric charge, which can be positive or negative, occurs in discrete natural units and is neither created nor destroyed. Electric charges are of two general types, positive and negative. Two objects that have an excess of one type of charge exerts force of repulsion on each other when relatively close together. Two objects that have excess opposite charges, one positively charged and other negatively charged, attract each other when relatively near. Many fundamental or subatomic particles of matter have the property of electric charge. For example, electrons have negative charge and protons have positive charge, but neutrons have zero charge, that is null charge. The negative charge of each electron is found by experiment to have the same magnitude, which is also equal to that positive charge of each proton. That means there are equal charge in proton and electron, but opposite sign. Charge thus exists in natural units equal to the charge of an electron or proton, fundamental physical constant. A direct or convincing measurement of an electron's charge as a natural unit of electric charge was first made in the Millikan oil drop experiments. Atoms of matter are electrically neutral because equal charges of proton and electron. Because their nuclei contains the same number of protons as there are electrons surrounding the nuclei. Electric current and charged object involve the separation of some of negative charge of neutral atoms. Current in metal wires consists of drift of electrons, of which one or two from each atom are more loosely bound than the rest. Some of the atoms in the surface layer of a glass rod positively charged by rubbing it with a silk cloth have lost electrons. While rubbing, some electrons lost from one element to another. That means the cloth to or glass rod to cloth, leaving the net positive charge because some electrons are leaving from one place, though it becomes a positive charge because it's some negative charge gone away. And because of the unneutralized protons of their nuclei. A negatively charged object has an excess of electrons on its surface. Electric charge is conserved. Means in any isolated system, in any chemical or nuclear reaction, the net electric charge is constant. The algebraic sum of the fundamental charges remains the same. The unit of electric charge in the meter kilogram second in SI unit system is the coulomb and is defined as the amount of coulomb is defined as the amount of electric charge that flows through a cross section of a conductor in an electric circuit during each second when the current has a value of 1 ampere. 1 coulomb consists of 6.24 into 10 raised to 18 natural units of electric charge, such as individual electrons or protons. From the definition of the ampere, the electron itself has a negative charge of 1.602176634 into 10 raised to minus 19 coulombs. An electrochemical unit of charge is the Faraday, is useful in describing electrolysis reaction such as a metallic electroplating. 1 Faraday equals this much, that is 96485.332123 coulombs. The charge of mole of electron, that is an Avogadro number, which is equal 6.02214076 in 10 raised to 23 of electrons is one that is Avogadro number. Next, we will discuss about electric field. Electric field is defined as the electric force per unit charge. Electric field is electric force per unit charge. The direction of the field is taken to be the direction of the force it would exert on a positive test charge. The electric field is radially outward from the positive charge and radially in towards a negative point charge. Electric field. An electric property associated with each point in space when charge is present in any form. The magnitude of the direction of the electric field are expressed by the value of E called electric field strength. Electric field strength or electric field intensity or simply electric field. Knowledge of the value of electric field at a point without any specific knowledge of what produced the field is all that is needed to determine that what will happen to electric charge close to the particular point. The strength of an electric field E at any point may be defined as the electric or coulomb that force F exerted per unit positive electric charge Q at that point, or simply E equal to F over Q, force by coulomb. If the second or test charge is twice as great, the resultant force is doubled, but their quotient that measures of the electric field E remains the same at any given point. The strength of the electric field depends on the source charge, not on the test charge. The strength of electric field depends on only the source charge, not on the test charge. Strictly speaking, the introduction of a small test charge, which itself has an electric field, slightly modifies the existing field. The electric field may be thought of as the force per unit positive charge that would be exerted before the field is disturbed by the presence of the test charge. The direction of the force that is exerted on a negative charge is opposite that what is exerted by a positive charge. The direction is changing from positive to negative charge. Because an electric field has both magnitude and direction. The direction of the force on a positive charge is chosen arbitrarily as the direction of the electric field. That the electric field direction is taken, the positive charge is chosen as arbitrarily as the direction of the electric field. Because positive charges repulse each other, the electric field around an isolated positive charge is oriented radially outward. When they are represented by lines of force or field lines, electric fields are depicted as starting on positive charge and terminating on a negative charges. A line tangent to a field line indicates the direction of the electric field at that point. At times, the electric field itself may become detached from the source charge and from closed loops, as in the case of charge accelerating up and down the transmitting antenna of a television station, for example. The value of electric field has the dimension of force per unit charge. In the meter kilogram second and SI system, the appropriate units are newtons per coulomb, equivalent to volts per meter. In the centimeters gram second system, the electric field is expressed in units of dynes per electrostatic units ESU, the equivalent to stat volts per centimeter. Now, further, to electrify a neutral body, we need to add or remove one kind of charge. When we say that a body is charged, we always refer to this excess charge or deficit charge of charge is charged particle. In solids, some of the electrons being less tightly bound in the atoms are the charges which are transferred from one body to the other. A body can thus be charged positively by losing some of its electrons. That means that body becomes positive charge. Similarly, a body can be charged negatively by gaining some electrons. When we rub a glass rod with silk, some of the electrons from the rod are transferred to the silk cloth. Thus, the rod gets positively charged and the silk gets negatively charged. Now, no new charge is created in the process of rubbing. Also, the number of electrons that are transferred is a very small fraction of the total number of electrons in the neutral body. So far, we discussed about electric charge and electric field. Some introduction we have done. Please subscribe our YouTube channel.